Hello, this is Mr. Kingsbury. I wanted to briefly provide you with some examples and some definitions and so forth about a specific topic. Today, in fact, our topic is going to be characteristics of square root and cube root functions. We're in our unit about radical functions here in our Algebra 2 class. The essential question today is, what are the important characteristics of square root and cube root functions, and how do I find them? So let's list them out first. So let's look at square root first. For the square root function, there are 5. You've got your x-intercept, your y-intercept, your endpoint, domain, and lastly, your range. For your cube root functions, there are only 4. X-intercept, your y-intercept, your domain, and of course the range. So let's just take a look at how to do each of these. I'm going to do about, 2 examples of each maybe. And I should probably beg your forgiveness right now. The graphs I'm going to give you are not precise. But that doesn't make what I'm doing any less important, because it's exactly what you're going to do. All right. So let's say, for example, that you have a graph of a square root function. Like that. And let's put its endpoint is right here. Let's say it goes this way. All right. So the 5 things we would look for are the x-intercept, the y-intercept, the endpoint, the domain, and the range. And I'm doing domain and range last because they are built off of the endpoint. So I'm looking right here. It does not cross the x-axis. So that's going to be a no or a none for x-intercept. But it does cross the y-axis here at 0, 1, 2, 3. So 0, 3 is going to be its y-intercept. The endpoint is right here at -2, 1. And I want to point out that all 3 of these are written as ordered pairs. If they're not written as ordered pairs, they aren't the intercepts or the endpoint. Now let's talk about domain and range. Let's start with domain. Because there's an endpoint, that means there is at least one stopping and starting point for the domain and the range. So the way we're going to write our domain and our range will express that. It will say, hey, all of the numbers start here and either get bigger or get smaller. So this is how I'm going to do it. Domain deals with x, so I'm going to write with x. I'm going to start with the letter x. I'm going to write x. I'm looking at this dot here. The graph goes to the right of the dot. That means I'm going to use greater than or equal to, because all of the x values on this graph are over here to the right of this dot. So I'm going to put greater than or equal to, because the endpoint is always included. And then the question is, what is it greater than or equal to? Well, it's just the x value of the endpoint, which is -2. So that's my domain. X is greater than or equal to -2. For my range, I'm going to start similarly. I'm going to start with y. And then right here, I'm going to decide, is this above the dot that I'm starting or below? This one is above. It's going up, right? We've got a positive slope, if you will. You could say that it is rising. So that means we're going to use greater than or equal to. And then we need a value that y is greater than or equal to. Again, that's going to be part of the endpoint. In this case, the y part of the endpoint. And you're done. That's it. That's all there is to it. Let me show you another one so that you have, another example to go off of here. Let me get my book straight. So here's example 2. And I realize that these graphs are not fabulous. Pardon me. Pardon me. I may have another one. Who knows? Let's see. Just because I want to get one in here that you guys can see. Nope. Let's do this up here. That's what I want. Okay. So here's my graph. You can see it has an endpoint here. It's going down and to the right. And again, we're going to look for the x-intercept, the y-intercept, the endpoint, the domain, and the range. Let's start with our x-intercept. Here's the x-axis. It crosses here at -2, 0. Then our y-intercept is here. It crosses at 0, -1. And then the endpoint is here at -4, 1, 2, 3, -4, 3. Again, these are all ordered pairs. By the way, I didn't mention this before, but if you'll note, the domain and the range are inequalities. Kind of important to remember. So let's build the domain and the range. Let's start with domain. Domain deals with x values. So I'm going to put an x. I'm looking at my endpoint here. It looks like if I were to divide this into a left side and a right side, this arrow is on the right side. So I'm going to use greater than or equal to. And then the number I put here is the x value of the endpoint, -4. Now let's deal with the range. Again, range deals with y, so I'm going to start with y. If I were to divide this into a top and a bottom, it looks like this is on the bottom. It's going down, it's going beneath. So I'm going to use less than or equal to. Remember up here, if I were to draw that line, this is going above the line, this is going below the line. So below the line, less than or equal to. Always you will use or equal to. You will never ever use greater than or less than. It'll always be greater than or equal to, less than or equal to. And then what number do I put here? I put the y value of the endpoint, which is 3. So y is less than or equal to 3. That's it. That's all it is for square roots. And cube root is even easier. Let me show you. Here's example number 4. I'm trying to draw with my best drawing ability. Okay, I know I only went out to 3. On the next one, I'll make it go bigger. Cube roots, they don't have an endpoint, if you'll recall. So all we're really looking for is the 2 intercepts and then the domain and the range. This is so awesome. So, and it'll look like an S, if you will. So it's kind of like, there we go. It's not perfect. We're going to look for the y-intercept, the x-intercept. I just said those backwards. I apologize. The domain and the range. So let's start with the x-intercept. Well, that's right here at 2, 0. And that's right here at, and the y-intercept is here at 0, 2. Is what I meant that to go through. I did not do a good job on that. My apologies, but it's supposed to be 0, 2. And here's the best part. The domain and the range are all real numbers, no matter what your graph looks like. That's it. It's that easy. Like, I wish it was harder, but actually I don't wish it was harder. I'm glad it's that easy. Let me do another one that maybe looks better. Why is that example 4 when that's example 3? Let's try that again, shall we? This is example 4. These are some of the best graphs I've ever drawn. I'm just saying. Alrighty. That looks good. So let's say for that one, let's say that's our graph, right? So you can see the x-intercepts here and the y-intercepts here. X-intercept, y-intercept, domain, and range. So x-intercept is here at -3, 0. And the y-intercept is here at 1, 2, 0, 2. And again, our domain is all real numbers. And the range is all real numbers. That never, ever changes, ever. And I just want to throw one other thing in here just as a reminder. For x-intercepts, I want you to remember this. For x-intercepts, they're always an ordered pair, and there's always a 0 in the y spot. And for y-intercepts, also it's always an ordered pair. But in this case, there's always a 0 in the x spot. Always. Okay? That's a very important thing to remember. That way you can identify points that are intercepts very quickly. If there's a 0 in it, it's an intercept. And wherever the 0 is, it's always the opposite one. See how the 0 is in the y? If you see a point and there's a 0 in the y spot, then it's the x-intercept because the x is the one that's not 0. Hopefully that makes sense. Anyway, I hope that helped you. And have a great day. Bye.